Grade 7 students. I am Jelly M. Marila, Mathematics 7 teacher of Bamban National High School.
You are listening to Serbisyong Putog Radio, DWSP 101.5 News FM. Yours truly is from Bamban National High School. Welcome to Mathematics 7 class. Our new venture in learning absolute value of a numbers and operations on integers. I will guide you in the first quarter on the third lesson this week. Are you all ready, students, to embark on the journey toward learning mathematics via radio? Wow, that's great! So our lesson for today is about absolute value of a number on a number line and operations on integers. Yes, you heard it right. Absolute value and operations on integers. In this lesson, we will help you to master in finding the absolute value and operations on integer. At the end of this lesson, you are expected to represent absolute value of a number line, add, subtract, multiply, and divide integers with like or unlike signs. Before we proceed to our lesson, I want you to forget you're afraid in mathematics. Feel love with mathematics instead. Embrace mathematics. Enjoy learning with this subject and be optimistic, because always remember that in every problem that we encounter, there is always a right solution. Sometimes we need to use only positive numbers, and the absolute value is a useful tool for this purpose. When you see an absolute value in a problem or equation, it means that whatever is inside the absolute value is always positive. It focuses on relationship between absolute value of a number as a distance of a number from zero and fundamental operations on integers. As we go on with the discussion, different activities were done to illustrate the absolute value of a number and fundamental operations on integers. The addition and subtraction of integers can be explained by using tiles and the rules. Now, let's proceed to our first lesson about representing absolute value of a number on a number line. You hear the word absolute value, right? What is an absolute value mean? Do you have any idea? That's right! When we say absolute value of a number, it is the distance of a number from zero. And always remember, distance itself is always positive. The absolute value of a number n is written as absolute value of n. Now, let us study the different rules in finding the absolute value of a number. First rule is, if x is positive integer, then the absolute value of x is positive. Therefore, the absolute value of x is positive x. It means that any number greater than 0, the absolute value is positive. Let us try. What is the absolute value of 7? Very good. Since 7 is a positive integer, then the absolute value of 7 is positive 7. Second rule, if x is equal to 0, then the absolute value of x is x. Let us try an example. Find the absolute value of 0. Yes, you're right. Since 0 is equal to 0, then the absolute value of 0 is 0. Is it clear? Now, let us study about the third rule. If x is negative integer, then the absolute value of x is the opposite of x, so that the absolute value of negative x is positive x. Therefore, any number less than 0, the absolute value is the opposite of a number. Example, find the absolute value of negative 10. Yes, correct! Since negative 10 is a negative integer, then its opposite integer is positive 10. Now, let us proceed in representing absolute value of a number on a number line. What do you think is the absolute value of 6? Are you familiar with a number line? Okay, let us draw a number line. Number going to the right direction are all positive, and numbers going to the left is negative numbers. Okay, let us plot positive 6. So let us count from 0 going to the right. So 1, 2, 3, 4, 5, 6. Since 6 is 6 units from 0, the absolute value of 6 is 6. Another example, find the absolute value of 0. First, draw a number line. Always remember that numbers going to the right direction of a number line is all positive, and numbers going to the left are all negative numbers. Then plot 0. Therefore, the absolute value of 0 is 0. Another example, find the absolute value of negative 3. Again, let us draw a number line. Then plot negative 3. Negative numbers are located from 0 to the left of a number line, so that we are going to count 3 units to the left. So 1, 2, 3. Since negative 3 is 3 units from 0, the absolute value of negative 3 is positive 3, or the absolute value of negative 3 is 3. To sum it up, the absolute value of a number is the distance of a number from 0. Remember, distance itself is always positive. The absolute value of a number represented by n is written as absolute value of n. We have already done with absolute value. Let's now proceed to our next lesson, which is operations on integer. The first one is addition of integers. Do you remember how you first learned to add two counting numbers? Did you use your fingers? Adding two integers is similar to addition of whole numbers. Operations of integers can be performed using different ways. As to addition of integers, let's make use of sign tiles and rules. Let us first discuss on how to add integers using sign tiles. Let black tile with positive sign represents positive 1. And the white tiles with negative sign represents negative 1. Now, when we combine one positive tile with one negative tile, they will cancel each other. However, when we combine positive tile with another positive tile, they appear as two positive tiles together. When we combine one negative tile with another negative tile, they will appear as two tiles together. Let us try. Combine 5 positive tiles and 3 positive tiles. Since the first 5 tiles are positive and the next 3 tiles are also positive, therefore, they will appear as 5 plus 3, which is equal to 8. How about if the given tiles are all negative? Okay, let us check. Combine 4 negative tiles and 3 negative tiles. Since the first 4 tiles are negative and the next 3 tiles are also negative, therefore, they will appear as together. So, negative 4 plus negative 3 is equal to negative 7. What if they are unlike or not the same? What are we going to do? Okay, let us have an example. Combine 4 positive tiles and 3 negative tiles. Since the first 4 tiles are positive and the next 3 tiles are negative, then the 3 positive and 3 negative tiles will cancel each other. Therefore, the remaining tiles will appear as only one positive tile. So, it is written as 4 plus negative 3, which is equal to 1. We are done with addition of integers using a tiles. Now, let us study on how to add integers using the rules. Rule number 1. When the integers have like signs, add the numbers and copy the common sign. For example, what is the answer when you add 8 plus 5? Okay, very good. Notice that 8 is a positive and 5 is also positive. They have like signs. So add 8 and 5, then copy the common positive sign. Therefore, the answer is positive 13. Another example. Add negative 13 and negative 12. What is the sum? That's great. As you can see, 13 is negative and 12 is also negative. They have like signs. So, add 13 and 12. Then copy the common negative sign. Therefore, the sum of the two integers is negative 25. Did you get it? That is all for like signs. How about if they have unlike signs? For rule number 2, when the integers have unlike signs, subtract the numbers and use the sign of the number with the greater absolute value. For example, find the sum of negative 2 and positive 4. Notice that 2 is negative while 4 is positive. They have unlike signs. So, subtract 2 from 4. Then copy the sign of 4, since it has the greater absolute value. Therefore, the answer is positive 2. Another example, Add positive 38 and negative 20. What is your answer? Very good! Since 38 is positive and 20 is negative, they have unlike signs. So, subtract the numbers. Then copy the sign of 38, since 38 has the greater absolute value. Therefore, the answer is positive 18. For you to easily remember the rules in addition of integers, I want to share the song Addition of Integers.
Same signs add and keep, different signs subtract. Take the sign of the bigger number, then you'll be exact. Same signs add and keep, different signs subtract. Take the sign of the bigger number, then you'll be exact.
To sum it up, when the signs are the same, add and keep the sign. When the signs are unlike or different, subtract and use the sign of the number with the greater absolute value. Remember, do not forget the rule in adding integers because we will use it in subtracting integers. We are done with the addition of integers. Let's now proceed in the subtraction of integers. When you work on subtraction of integers, you use addition to calculate the difference. Subtraction is the inverse of addition. To subtract signed numbers, change the sign of the subtrahend and then proceed as in addition of integers. That is, if a and b are any two integers, then a minus b is equal to a plus negative b. Then, follow the rules for addition of integers. Follow this rule number 1, KCC, or keep, change, change. K is for keep, which means keep the first integer the same. C is for change, change the subtraction sign to addition. C is for change, change the sign of the second integer. Then, after that, follow the rule number 2, which is follow the rules for addition. When the signs are the same or like sign, add and keep the sign. When the signs are different or unlike sign, subtract and copy the sign of the number with the greater absolute value. For example, subtract 7 and 3. Follow the rule, which is KCC. K for keep, the first integer. We need to keep positive 7. Then next is C for change. Change subtraction into addition. Next, C is also change. So from positive 3, it will become negative 3. Then follow the rules in addition of integers. Therefore, 7 plus negative 3 is equal to positive 4. Another example, 4 minus 5. Follow the rule again, which is KCC. So we need to keep positive 4, then change subtraction to addition, then last C, change positive 5 to negative 5. Since unlike sign, subtract the integers, then copy the sign of the number with the greater absolute value. Therefore, the answer is negative 1. To sum it up, the rules in subtracting integers is KCC. K, keep the first integer the same. C, change the operation from subtraction to addition. Then C, change the sign of the second integer or the subtrahend. Then follow the rules in addition of integers. When the signs are the same, add and keep the sign. When the signs are unlike or different, subtract and copy the sign of the number with the greater absolute value. We are already done with addition, subtraction of integers. Let us now proceed on the multiplication of integers. The repeated addition model for multiplication can be extended to multiplication of two integers, in which one of the factor is positive. However, for products in which both factors are negative, repeated addition does not have any meaning. Hence, multiplication of integers will be discussed in two parts. The first part, look into products with at least one positive factors, while the second studies the product of two negative integers. Now, let us start our discussion on the rules in multiplying integers. Rule number 1. When you multiply two numbers with the same sign, the product is positive. Rule number 2. When you multiply two numbers with different signs, the product is negative. For example, multiply positive 6 and positive 9 is equal to positive 54. Why? The product is positive because the sign of the factors are the same. Another example, what is the product of negative 7 and negative 6? That is positive 42. Why? The product is positive because the sign of the factors are the same or both negative. Next example, multiply negative 8 and positive 5. The answer is negative 40. Why? The product is negative because the sign of the factors are different or they have unlike sign. How about if we multiply 0 times positive 10? What will be the answer? That's great! 0 is the product because any number multiplied by 0 gives a product of 0. To sum it up, when you multiply two numbers with the same sign, the product is positive. When you multiply two numbers with different sign, the product is negative. When you multiply any number by 0, the product is 0. We are done with addition, subtraction, and multiplication. Last one is division of integers. This is a short lesson because the sign rules for division of integers are the same with the multiplication of integers. Division is understood as the reverse operation of multiplication, hence making the rules the same with respect to the sign of the quotient. Let us first discuss the rules in dividing integers. Rule number 1 is when two numbers with the same sign are divided, the quotient is positive. Then rule number 2 is when two numbers with different signs are divided, the quotient is negative. Rule number 3, the rules for dividing 0 by a non-zero number and for division of 0 still hold. 0 divided by non-zero number is equal to 0. Any number divided by 0 is equal to undefined. For further understanding, let us have an example. For example, positive 45 divided by 5 is equal to positive 9 because the signs are both positive or the same. Another example, negative 51 divided by negative 3. The result is positive 17 because the signs are both negative or the same. Last example, positive 273 divided by negative 21. The answer is negative 13. Why negative? Because the two integers have unlike signs. so the result is negative. To sum it up, when two numbers with the same signs are divided, the quotient is always positive. The quotient of two integers with different signs is negative. So, that's how you learned absolute value and operations on integer in the new normal way. Alright, you can practice your skills more in this lesson by doing your activity sheets. I hope you learned from this discussion.
Once again, this is your radio teacher, Teacher Jelly M. Marila of Bamban National High School.